Hey there and welcome. Today, we are going to tackle one of the most important skills in all of algebra, changing the subject of a formula. Now, this isn't just about passing your exams, it's about turning these really complex, kind of clunky equations into simple, sharp tools you can actually use to solve problems. So let's kick things off with one you probably already know. Just think about it for a second. We all know the area of a rectangle is length times width, right? But what if you're given the total area and the width and you need to figure out the length? You kind of just know instinctively that you have to rearrange that formula. Well, that simple little act of flipping an equation around, that's exactly what we are going to master today. So, why are we spending a whole explainer on this? Because this one skill, it's like a secret weapon. It's the key that unlocks problems in physics, in finance, and, yeah, most importantly for a lot of you, in those really high-stakes exams. It's all about taking a rule and making it work for you. And trust me, this skill is super practical. We are not talking about some abstract math theory here. We are talking about calculating acceleration in physics or figuring out interest rates in economics. And for students in Nigeria, this is absolutely non-negotiable. You'll see it all the time in WAEC, it's a quick way to score points in JAMB, and it pops up with real-world examples in NECO. Mastering this means you're just going to be faster, more accurate, and a whole lot more confident. So, how do we actually do it? You might be thinking that every single formula needs its only special trick, but that's just not true. There is one universal key, a simple set of rules all about reversal that can solve any of these problems. Let's unlock it together. I love this analogy. The whole idea is to think of it like peeling an onion. See, every formula is built up with layers of operations. You've got additions, multiplications, squares, all sorts of things. Our job is to just undo those operations, one by one, in the reverse order they were put on. We're just peeling back the layers to get to the center, and that center is the variable we're looking for. And it all comes down to this really simple three-step method. First, you lock onto your target. Find the variable you need to get all by itself. Second, you start peeling that onion, using inverse operations. You know, the opposite of adding is subtracting. The opposite of multiplying is dividing. And third, once your variable is finally alone, you just tidy up the other side to make it look neat. That's it. That is the entire game. Alright, enough with the theory. Let's put this method into motion and see how it really handles actual formulas. We'll start with the classic from physics and then, level up to something a little bit trickier. Okay, here we go. We've got the formula for final velocity. Our goal, our mission, is to get A, that is acceleration, all by itself on one side of the equal sign. Now, if you look at the right side, A is being multiplied by T. And then, U is being added to that whole chunk. So what's the first layer of the onion we need to peel off? And boom, there's our final answer. A equals V minus U, all over T. So how do we get here? It was just two simple steps. First, we undid the addition by subtracting U from both sides. Then, we undid the multiplication by dividing both sides by T, simple, clean, and we're done. Okay, let's try a more intimidating one. This formula for displacement has a fraction, and our target, A, is buried inside a term with a squared variable. But look, don't panic. The rules are exactly the same. We just have a few more layers of that onion to peel back. And there's the solution. It equals 2 times s minus u, t, all divided by t squared. Now, it looks complicated, I know. But the steps were the same. We just peeled back the layers systematically. First, we subtracted u and t to get the term with a by itself. Then, we multiplied by 2 to get rid of that fraction. And finally, we divided by t squared. See? It's the same method just applied with a bit more care. Now for the ultimate test. It's one thing to do it here with me, right? But how does this look when you're under pressure in an actual exam? Let's take on some real past questions from WAEC and JAMB. Alright, here's a classic from a 2018 WAEC paper. It's the good old formula for the perimeter of a rectangle. Our mission is to make B, the breadth, the subject. Right now, B is kind of trapped inside those parentheses. And the whole thing is being multiplied by 2. So, what's our first move going to be? And the solution is B equals P over 2 minus L. We got B alone by first dividing the whole thing by 2 to break open those parentheses. And then we just subtracted L from both sides. Now, the super important exam tip here is about speed and accuracy. WAEC designs these questions to be quick wins. So, practice them and always do a quick mental check. Let's switch gears and look at a JAMB question from 2021. This is the formula for the period of a pendulum. This time, our target L is trapped inside a square root. This adds a totally new layer. How in the world do we peel back a square root? After peeling back all those layers, we arrive at our solution. L equals G times the quantity T over 2 pi squared. The key moves were dividing by 2 pi to get the root alone, then squaring both sides to kill the root and finally multiplying by G. The tip here is absolutely vital for JAMB. When you see squares and fractions, don't rush. Go step by step to avoid making simple, costly mistakes. Okay, we have covered the theory, the method, and some real-world exam questions. Let's put everything together into a final cheat sheet so you can walk away with exactly what you need to know. So, just remember the core process. 1. Know your target. What are you trying to isolate? 2. Use your inverse operations to peel back the layers around it. That means addition, subtraction, multiplication, division, even square roots. And 3. Always simplify your final answer carefully to avoid silly errors. That's the foundation for all of this. And for your exams, here is the specific strategy. For WAEC, they love multi-step problems, so be sure to show your work. For JAMB, it is a race against the clock, so you need to practice until this stuff is second nature. And for NECO, be on the lookout for formulas from other subjects like physics or geometry, and always double-check your positive and negative signs. And look, if you remember nothing else from this entire explainer, remember this one thing. It's not just a math problem, it's a puzzle. You are simply working backward, step by step, peeling away those layers to reveal the answer that's hiding in the center. So, there you have it. We took a confusing algebra task and we turned it into a reliable, powerful tool. So my final question for you is this. Now that you've mastered the art of solving a problem by working backward, what other challenges in your studies, or heck, even in your life, can you solve just by learning to think in reverse? Thanks for tuning in.